Okay, hello. Let me see. This camera is doing a mirror. Can I undo the mirror? Oh, hi, I see on the chat, John. Can you hear me? Does it work? I will probably be spend the next 5 minutes mostly testing stuff, and then a Tate will actually go. Stream doesn't look like I can undo the mirror of the camera. That's pretty annoying. And I had two cameras. I thought I'd be able to change between them. But I guess all that may be advanced stuff. That's the first time I do a live stream myself, so I don't know what the options were. All right. Looks like I won't be able to. I have the other camera to show my face and talk a little, but I'm not able to switch cameras. So we'll just do with the one I set up for the actual stream. Oh, nice numpad. Thanks. Yeah, it's a ramen numpad, and then because I just got delivered the laser keycaps that I'm going to be using hopefully in an upcoming build with the gherkin, but I get way more keycaps than I have key slots, so I put the numbers there. It's just it's the special set that has like the one is a 10, and then instead of putting the 80, I put the 88, which I think is a reference to Back to the Future. The mirror image of the camera is really bothering me. I wish I could just click somewhere to and mirror it. Gonna wait another minute, and basically when it's 8 p.m. Eastern time, I'm in New York. I will start. I don't know, more people will join. It's okay. It's only 4. My main goal of this, I was going to do the videos on my own and then put them on the site, but I feel doing it as a stream may be more helpful, so I can get basically a value of the live chat of you telling me, hey, what is that for? And a little bit of feedback. So then I make a better assembly video than just on my own, mainly because I do know how to assemble, since I've assembled it so many times already. I disassembled this actually a couple hours ago, just for now. All right, it's 8. All right, let's just start. I don't know why you're wearing the headphones when I'm not listening to music and I cannot hear anything on this chat. Those feels a little weird though talking in this quiet room. But so this is to assemble the MSG Cyberdeck that I put together. I first completed this last summer, this Cyberdeck, but it was very unwieldy to assemble. There were lots of cables inside. There weren't room for it, and several of the plastics, as I screw them, they will bend because the design wasn't that great for that, and some parts didn't fit very well. So the keyboard was a little loose, for example. There were a few issues. Like the look was okay, but functionally there were a bunch of faulty parts. And so, but a bunch of people, especially on the YouTube, ask, "Can we get a video? Is there a way to see how to assemble it?" And it will have been an ugly video. And now I've made a bunch of updates to it to make it much easier to assemble. And now I have the confidence that I'll be able to show how to put it together. And so what I did is this afternoon, after logging off work, I disassemble it. I put it all on a table. And what I'm going to do now is kind of putting it back together. Obviously, there will be a lot of stuff that I already done before as I prepare, but I will explain, and hopefully that's helpful to anyone trying to assemble their own. And also, I just got delivered this webcam arm, so I'm going to try to flip around. Let me see if I can get that going. Not here. You stay put, and you move a little there. Okay. Now we go around. And what I have here is a table where I set up all the parts that I'm going to be basically assembling for the MSG. So let it settle a little. Stop shaking. We can see here the case, the basic part, but we also have the ribbons that we're going to be using, the plain keyboard, the cover for the back plate, the e-ink and the microdot that we're going to be putting, the one rat nest, which we'll talk about later, which is the KVM, and it's quite modded, I guess you could say, with all the stuff I've done to it. The screen, the back of the screen, and here at the corner, I'm not sure it's not on camera, that's the Nook, and the new very fancy strap my wife put together to carry it. So let's get started. This is all the parts we have, and I'm going to be grabbing them, bringing them to my cleaner desk, and we'll be putting it together. And feel free to type and cut me as I assemble stuff with anything that could be helpful or that you would like to know. Set that up. Camera is a little off. In these things, I'm a little monk. When these things misalign, just bother me. Yeah. It's a little more like this. And then, sorry about that. I always spend so much time doing these things. It's the time that I should be using for other things. All right, that'll be good enough. All right, well, let's start with the main base part. And what have I done to that? I print that. I removed the supports. There are very clean supports on the Raspberry Pi side because we have the Raspberry Pi actually comes, there is an indentation for it, so it's kind of quite sculpted. And the back, it's actually a pretty thin wall. The camera will get to focus onto it. And I did quite a bit of detail. Like you can see the little clip for the Ethernet, and and stuff like that there. If you're paying attention, you may notice that if you're familiar with the Pi 4, we are missing one USB-C, one USB box. With the USB, the Pi has 4 ports. We're losing one because we're going to be soldering under the Pi 4 to power, to get basically the USB for the screen, keyboard, mouse, all will be from that USB port we are sacrificing here. We have the supports I didn't do a very good job of removing because I didn't care since they are internal, which are these here. And that's because I did want a solid, strong bar of plastic here. In the prior version, this pretty much went all the way down, using way more plastic and also having way worse thermals and leaving way less space for the cables. So all this empty space now is going to be very, very handy to use cables, to get better airflow for the different parts, and save plastic and printing time. Here we have the ports for the NUC, which also have been cleaned since the version 1, and the port for the large USB, which we're going to plug the mouse. What else have I done? You probably have noticed I added a ton of heat inserts. Realistically, 6 screws should be enough. But for aesthetic purposes, I added a lot of them. And instead of just making 6 true screws and a lot of aesthetic ones, I just make them be all kind of working screws. And that way, we don't worry about if one fails. We have a lot of backup. There's some helicopter action going on around here. Don't know why. And the next thing, and you may be like, oh, that's a little ugly. What have I done? I added tape. Why? Because we're going to be putting the keyboard here. The version 1 had the keyboard kind of stuck in and tried to hold in place. That was pushing the PLA, and PLA versus the metal of the keyboard wasn't a very good way to hold the keyboard. So it was either bending the PLA out or the keyboard was loose. What I found made a way better job was to leave just 0.2 millimeters or something, a little extra space on the keyboard, and then add just tape, just electrical tape. That creates a good kind of rubbery section that holds the keyboard in place much better. And now I see little comments. Doesn't focus that close. Just hold it further back. Does it do a better job? But it's the camera. It's just so blurry. What's going on there? Is it because it's shaking? Let's see. Yeah, this camera now is doing a pretty shitty job at being a camera. I'll wipe it. It's not. Is it focusing? It's not focusing at all. Yeah, I can't even read the. Oh, I'm getting some focus now. Okay, so maybe it focuses at a little higher. Going fully for 3 seconds and then let it focus. Let's try that. Put my hand there. Oh, that's well. Yeah, that did it, right? Yeah, now we can. It's much better. Cool. Thanks. So that's the base, and that's where we're going to start. We're going to do some easy start. We'll insert our big USB port on the side. And what have I done to this USB port? I Dremeled it a little flat on one side. So basically, it will let the keyboard the keyboard will sit on top of it without pushing anything. So now this is basically just flush with the side there. Now we have that in place. It looks flush. It's all pretty good. Then we can put the KVM I don't have a set order how to install things. In the version 1, you have to be very careful because putting one thing blocked another. For example, once you put the nuke, you couldn't put the keyboard. Now it's pretty flexible. You can put any order you want. I'm going to go over the KVM because it's a rat's nest, and it's the part that may be more confusing to see. So what we have here is just a $35 KVM from Amazon. That what it does is has inputs. One has HDMI input, USB input for one computer, HDMI input and USB input for another computer, HDMI output, and HDMI and a USB into USB outputs. What we modeled here is I did not touch any HDMI because I've never succeeded or really tried to solder HDMI ports, and just seeing how many pins an HDMI cable has kind of scares me. USB 2.0 on the other side is 4 wires. It's pretty easy. It kind of always works. So here we have the one computer, we'll have the HDMI, and we have the USB. So this one is going to plug on the back of the NUC, and basically that's going to be the NUC screen. The USB will take care of the screen touch, the keyboard, and the mouse. And then for the Pi, since we are soldering on the bottom, the pads of the Pi, we're not really using the USB port. So to save space, I just solder a 4-pin connector. I think it's a JST connector. Then we have a USB output, which I solder a USB-C type, a USB-C but type 2, so kind of a very the oldest USB-C you'll probably see around, which plugs on the back of the plank. Between the plank, if we look at the plank and the NUC, this is actually more space than we have for the full deck. That's how it goes. This is basically more space than we have for the deck, and we need to make room to have the USB connection. So this was the thinnest USB-C connector I found, and I dremeled it quite a bit here again to gain a space, and that's basically gonna fit here, taking the minimal space we need to be able to plug the keyboard without soldering, so we can keep it all as it came from ASDrop. So actually modding basically the expensive parts, I try to not damage, instead damage the connectors. What else do we have? We have another USB port, but we don't want 2 USB ports. We want 3. So I use Retrocution that's a USB hub, but it's a USB hub which is just a PCB, and so we get USB in, which we use from the KVM. And we have it has 4 USB outs, but I only use 2 at the moment. One that is going to go to the screen, and I kind of just paracord, this thing is called. I basically made a little bit of a not fancy looking USB cable for the part that is going to be outside of the NUC. And this part will come out and connect to the screen. And then a second USB internal, which is going to plug to the big connector for the mouse. And so that means that we're going to be able to control all that by pushing a button. How we control that button? Because I just yanked out the 12 millimeter button or 8 millimeter push button that was there, and instead I just solder a couple of wires, and we'll have a button for that. And the version 1, that was kind of just sitting there in a box. In the version 2, I made an indentation for it and made the screws that match the PCB holes. So we're going to go ahead and do our first screwing tonight. We're going to use a lot of screws. All of them are going to be either M2.5 and M3. And the distance don't really matter, but I got a bunch of 6, 8, 10, I think some 4, 12 millimeters, some 14 millimeters. If you're interested, I can try to find a list of all. But things like the one we're going to be putting right now, it really doesn't matter if it comes out a little. So you shouldn't worry if I'm using now a 6 or an 8, because that just goes through the bottom, goes through the PCB. Then we're going to put, a washer on the other, a nut on the other side, and it's going to hold it. And we're not going to care if 1, 2, 3 millimeters come out over the PCB. Oh, that could be it. Oh boy, that did not help. I really don't know how the focusing works. That's why it's so crappy. Oh, this girl. Yeah, stop calling me. Hope get to the. Oh. This camera, that's garbage at this point. Oh, please focus on something. Oh, okay, magic. I don't understand how that works, so to me it's just magic. Blast, I hit accept call, but I don't hear anything. I don't hear anything. Started the call. I cannot hear you. Yeah, Blast, I cannot hear you. What's going on here? Impute device. Should call. I'll close this code and open again. Oh, this. Yeah, that was the second webcam that was supposed to be to show my face, but it didn't work because I don't know how to change webcams. Now I'll open Discord again. No, never mind. Blast, I couldn't hear you. I don't know. Maybe there is something wrong with my Discord. We don't really care if those screws are very. Actually, as a matter of fact, we don't want this thing to be too tight. We don't want it to crack the PCB or damage anything. This is just to hold it in place. And because we're holding this tiny PCB with 3 screws, we're pretty safe that they don't need to be too tight, and it'll hold it in place pretty well. Plus, doesn't have a lot of room to go because it's going to be cased by the NUC, by the Raspberry on the back, and the keyboard on top. And we have a couple of blocks on the side that hold the keyboard, but also hold it in place a little. Cool. So now we have this thing connected. Earlier, we connected the USB ports. We can go ahead and plug that. Let's go with that. Okay. Next, we already have the NUC here, so we can plug it. What have we done to the NUC? We have the 2.5 barrel jack. All right, let's try again. This one is going to fail because then we can have the third time is the charm. Join call. What? Okay, so my speakers work because I just played with Winamp Player. Recommending Winamp Player to anyone. So the speakers work. Discord voice don't seem to. There is the voice channel, the happy hour on Discord. Do you want to join that? Plus, instead of the call, maybe the call just doesn't work. And also, I guess if that happens to work, then others can join as well. Drum roll. User settings, audio. Let's go back. Blasto, are you saying anything? Yes. Okay. Finally. All right. So that works. So I mean, then we have 9 people watching. Assume that I know you probably are familiar with the Discord. The Discord has a 24/7 happy hour channel. By Discord, I mean the Cyberdeck Discord. If you join it, I guess now we'll have a voice chat going on there. Yeah, it took a little while. And there is a good chance that I have issues because I'm playing the live and that everything goes wrong when I'm stressed. So I was saying, we're going to put the NUC now. What have I explained all I've done on the KVM. What have I done to the NUC is I made a little connector for the power, which is just a 2.5, I believe, millimeter barrel jack. And we're going to connect here the power input where we have a female that's going to go outside. And the more scary part will maybe these 4 wires to come out of here. The NUC, you will have to open anyway, the NUC, because it comes without a RAM or without an NVMe. And when you open, you're going to see that the PCB actually has some ready-made connectors. One of them is an 8-pin connector. And I used to, at the beginning, I'm like, try to use all 8 ports there. And here is is it focus or not? I mean, the focus is getting much better. I think Boot was right that that was the other camera arm and the water bottle were making a mess. Good. There is 8-pin connector, but it's to use for the LED for the power, LED when the hard drive is thinking, reset, power on, all that stuff. I'm not sure I care for the LED of the hard drive working, and I didn't put a reset because you can just turn it on and off like everyone does by either clicking with the mouse or the front panel button. So I only use 4 of the connectors, 4 of the cables, and I just prepare the connector with those 4. This end is like that. The other end is just basically an 8-pin connector, of which I am only using 4, and it's plugged inside. So we're gonna go and put it in place. That's the NUC. I didn't do anything to it. You don't see a top, but the top is just a plastic top that I didn't use to keep it thinner. And then it comes with these little legs. I didn't even bother to remove the little legs. What I did is space for them, and that is good because the legs are a little rubbery, and so now they're settled better. And a couple of holes for the screws we're gonna put on it. So now we can put that in place. It should fit there. Good. Click. From the bottom, we're gonna make sure that all legs are kind of flush, at least close to flush. We want to make sure that no part is not in place. And pick up the screws. There. And actually, for that, I'm gonna start using. I'll bring here the. Oh. Yep, I'll do that.
You don't have to reply to your copy.
Okay, it's hopefully better now. I had this backwards. Cool. When I start using the electric screwdriver, we want to be very careful. This is PLA is not very strong. PCBs are not very strong, so we definitely don't want to be tightening stuff very well. We're not trying to hang a TV on the wall here, but we're going to be doing a lot of screws, so we don't want to also tire our wrist. So we're going to grab the screwdriver, setting it at the weakest setting. I much rather have this like click, click, click and get a stack than push through and basically damage something. So at the minimal, the weakest setting, just for the purpose of not overloading your wrist. Look for the right there. Right hex connector. And we're gonna start covering ground. When you have a few screws, I don't know how good that is, but pretty much every single instruction book will suggest to do them a little bit one, a little bit another, instead of each one fully at the beginning. So everything is a little more balanced, a little bit. Okay, so we're now good. Now it's a solid. The NUC is secured. The KVM is secure. We're gonna put the Raspberry Pi. Okay, so what do we have here? We have the Raspberry Pi 4. What have we done to it? We grabbed the. I originally soldered the pins directly on the. Those are USB 2 ports that are USB 3, much faster, many more pins. Originally, I will solder to the 4 of the USB 2. Someone mentioned that he heard somewhere that maybe the USB 3 get access data or power earlier, but don't quote me on that. That may be bullshit. But then I were like, whatever, just in case it's true, I used one of the USB 3s. We still have another one, so if you actually want to plug something that uses USB 3, you still have one available. So we'll be fine either way. So we solder on those little pins of the USB, and that's going to be what we're going to use against KVM. Then we added a hat with a couple of 18650s. Not a lot of go time, but definitely some go time, and ease to recharge as well. We have the barrel jack that we're going to have access to charge the Pi, and to use that barrel jack, I put together, find it there, a cable with matching paracord, so we can plug that 20 USB, probably a wall plug of USB that we have nearby. That cool it as much as 3 amps, I believe, when it's charging. So if you plug your computer, you may get the USB overload warning. And then we top the whole thing with a hacker hat, which helps to hold things in place. Adds a bit of a cover. It's a PCB, so it's decent material, and gives 2 sets of 40 GPIO pins. We're going to use both of them with ribbons. So that means that we'll put the ribbons, we'll run something, but if you want to test something else and you need all GPIO ports, you'll be able to unplug those ribbons and test something else in there. And at some point, I was playing with the idea of adding extra battery cells, and you can plug an extension here. I have the extension, I plug it. You obviously, instead of 2, the extension add another 2, so you get 4. You double the runtime. But I just couldn't find place for it without making some big sacrifices in the design. But I left the little connector as maybe one day. The whole thing is indented. Let's see if we get to see it. So again, it's all pretty tight to where the Pi will go. There is room. We're going to put at the bottom. We have 4 millimeter standoffs. That's 4 millimeter standoffs give room for the SD card, the cable with the cables we added, and everything. And we'll just screw that in there. Because those are very short standoff, we're going to be using, I believe, 4 millimeter screws. Some tiny things here. But the 4 of them hold it pretty well. Here. Almost all the screws we are using are countersunk, and that I took into account when I made all the fusion designs. So all of them should kind of come flush with the PLA. Change to this thin Phillips head with the extension. This one, if you do it right, well, actually, we should have checked on the nuke. The nuke kind of is easier to set, and generally everything, as soon as you screw everything, you get a pretty tight look for the thing. You can see everything is basically centered. That's what we're looking for, a hole that centers the audio. And those may look like extra large holes, but what I found is that several of the things I plug actually have pretty annoyingly large boxes. So if you don't have that much space, they just kind of sit on top of the PLA and don't really make connection. So I made fairly large holes for those. And for the Pi, we're going to align. If we do it right, everything should align there. Let's get that on. Where is pretty quiet? Oh. Yeah. Yeah, but it's good having you plaster around here. Do things like put the cap back, confirm that people can hear me. Wait, oh, that's the wrong screw. Oh, I lied earlier. I said that all screws we're going to use are 2.5 or 3. We're going to use 2 instances of 2mm screws. And I always forget about those. And now a 2mm screw just try to make its way to pretend to be a 2.5. That's not the 2. Oh, right. Maybe I should just move that more to the edge of the table. Right there. Yeah, maybe because what I do, it's kind of hard to reach if I extend the arms. Okay, I need to focus here because that is an M2 screw. That's an M3. We're looking for something just as short, but M2.5. That's the other M2. And let's try to find that boy will do. Is that too long? I think that's too long. If not, I'll skip it. 3 screws for now will do the job. It's definitely just a matter of a 4th screw, probably an M2.5 4mm. I wouldn't be too surprised if my dog ate it. She'll get some minerals out of it. There. Good. Right. So now we have, and again, as we want it to be, all the ports align neatly with the place where it'll be, and here is where we're going to be charging it. Good. So now we have the KVM, we have the NUC, and we have the Pi, and we're going to start. We can plug some of the things. We know that the NUC we're going to use the bottom of the 2 USB A's the NUC has on the back. We're going to use the bottom for the KVM, and the top is a small loop, which is pretty annoying to install. We'll find it later, that runs the back bay. And then we have the 4-pin connector that comes from the bottom of the Pi with the 4-pin connector on the KVM. So we plug these 2, right? Good. Okay. We have we're gonna start putting some of the HDMI cables in them. 1, 2. There should be 3 HDMI cables. Oh, it's actually here. Cool. So we have a 6-inch. Very. This line is I think it's a monoprice line. I don't know if there is any one that is even smaller, but that's just the smallest HDMI cables I was able to find. As smallest in terms of the connector. Where we really care here is connector and a little bit the cable size. Length 6 inch and 12 inches fine. And we have we know that we just plug to the NUC that one, so the one next to it must be for the NUC as well. They pair the USB with the HDMI, so we're gonna plug that. We're gonna connect it. I may actually not connect on the NUC now because I actually have this HDMI cable that is pretty strong, double duty. It's gonna hold some wires down because here is where we're gonna have the fan, and we don't want some thin wires or small wires kind of hitting on the fan. So we're going to be putting some small cables and use the HDMI, which is much stronger, to hold them down. And we have the HDMI to micro HDMI. It's a huge connectors. I wish I could get something like just look at the difference between these two guys. But I couldn't find a micro HDMI to HDMI from that line of monoprice. So unfortunately, we're going to use some massive connector for the teeny cable. Will be one of the advantages if the Pi 4 just use full-size HDMI. We'll be using much smaller cables. Do a little loop. And connect there. We're going to connect it to the left to the HDMI cable close to the USB-C port because that's the main one for the Pi. The other is for the secondary screen, which we're not going to be using here. Okay, so now we have all the KVM to NUC and Pi plugged, except this HDMI we're going to do later. We have that is going to be the USB, micro USB for the screen. That's going to be the 1 foot or 12-inch cable for HDMI for the screen as well. All right. Something that we're going to need to do is that the UPS we are using, the power supply for the Pi, comes with some protection that we want to use. Now I forgot which protection it is, but you can go look it up. That's the board is X728. But that protection needs to it works with these 3 jumper wires here. Oh wow, there's a lot of text on the chat. And I'm going to remove the jumper wire. If the jumper wire is on while you have been messing with the batteries, the whole system shuts down after 3 seconds, and it's going to be on a loop shutting down. Once you remove, the system will run on. Then after it's been on for 3-4 seconds, you can put the jumper back on, and it'll work just fine. And because I've been messing with the stuff earlier, I'm going to do that. Something that could happen is that sometimes when you put the batteries, it just turns itself on because it gets excited. Sometimes it doesn't. Okay, so we're good here. What could be doing next? Maybe we can add the keyboard. So we have all that here. That's going to be the cable for our keyboard, which comes from the back. Oh, the keyboard or maybe the buttons. I think it may be easier to get the buttons first. From panel, that one will be the NUC on and off. I didn't remove them. I mean, there is not a whole lot going on here, and I just tightening them. I like it's. I don't know if you want to see the X is off center, which makes it, again, I'm just ludicrous on these things, annoys me. So I make sure that the X is off center, but on the lower side. So I can make it be where I want it. And then however I can with my, as I screw it, I hold it with my fingers and try not, because if ideally you will hold it with a chain lock here and then a screw, but then you're going to destroy the thread. So I can very softly hold the thread with my fingers as I tighten it up. But once I tighten it up, I don't want to be moving much. So we have the button for the NUC, the button for the Pi, and the switch for the KVM, which doesn't have a light. On the back, we added, there are 2 glue parts in this build. I avoid glue as much as possible so I can do things like I'm doing today and build the thing, build it back together without damaging, destroying anything, without committing to every time I want to do a change, having to reprint parts. The gluing here is because any screws or anything I added, there was not enough room virtually to hold this panel. So I glued the yellow panel to the blue one. And for a very similar reason, for the LED panel, I glued an inside panel. Because this light color PLA, the Spider Maker, lets a lot of light go around. So I wanted to have an inside, a kind of a darker color PLA, so my LEDs show just a neat dot instead of kind of a diffuse big circle. Also, because they are different colors, I'm finding out that LEDs of different colors don't shine the same. So you can have 3 LEDs that are supposedly the same kind of 5 volt and all, but one appears way more bright than the other. By narrowing down to very small holes, you kind of diminish the impact of that. Anyway, so we're gonna plug our buttons. We have the NUC. The NUC uses 4 cables, because we use, what are we using? 2 for the LED and 2 for the power button. The Pi, we're gonna, sorry, something? Which is great if you're never gonna change the world. The glue also holds the Lego movie, what is it called? The Craggle? Craggle holds the world together, but then the world can't move. So we have the connector for the Pi. We are going to control the Pi through, and it is pretty crappy because I don't like how it works. The Pi, not through anything on the Pi, but through the UPS, the power supply. The power supply has this 4 connector here, but reality is 2 are for the LED, 1 controls the on and off for the Pi, and 1 is supposed to turn an LED for when it's under 25%. Haven't seen this LED ever working. And the button is supposed to have 2 or 3 features, like push to turn on, hold 2 seconds for a reboot, hold 3 seconds to turn off proper, 10 seconds for the force off. The only thing that I've seen working is push to turn on, hold 10 seconds to turn off. The other things, haven't seen them working. I've seen people on the Geekworm wiki describing what's happening to me as happening to them, and I haven't seen it addressed. So it is what it is. All right, so now we have the 2 buttons connected, and we're going to connect finally the KVM switch. Let's make sure I haven't lost it somewhere there. There you are. It's going under the HDMI. I guess I don't care if it goes under the HDMI. That's where you want to be there. Correct. Once you glue it, you are creating one part. And because 3D printers are so slow, if you're going to pay, if you glue a 20-hour print to a 3-hour print, and you then want to change the 3-hour print, you're kind of committing to a 29-hour print. And because the printers we use aren't flawless, a 29-hour print sometimes becomes a 75-hour print. And so you really don't want to be having this, because you want to make a change to a 3-hour print, commit to like 70 hours of printing, for instance. So I really avoid glue, and I especially avoid glue attached to any large print. This one is a 20-minute, I think, half an hour print. The inside is a 15-minute print. The whole thing is well under an hour. 40 minutes should be more than enough. That one is a little more demanding, not because the print is that much, but because I try to get it, as pretty as possible. But even then, that's maybe 4 hours, 3 hours, and then the panel is nothing, 15 minutes. But yeah, that one, at some point I was considering having different colors on the back, but I gave up because changing colors on the back is not the 15-minute of the back colors, but the 4 hours for the front to glue. So it sticks to that color. All right, now we have the buttons all wired up, and we can go. Yeah, we can put the flank keyboard in there. Oh yes. Oh, but I'm pulling off a screen, and that's something that is critical during the assembly. Right. Yep. So the cables here are all made a little bit too long. Why? Because we want to be able to put the keyboard in and out by just unscrewing these 6 screws on the front panel. If I wanted to be able to do that without going to the edge of the table, these cables will need to be basically as long as the keyboard, or pretty long, for me to kind of move that to the side, put the keyboard, and bring it back. By going to edge of the table, they are just a little long. I let that fall a little bit, and now I can put the keyboard in, make sure that all is good, nothing is trapped anywhere. And a big thing, I'm able to connect the keyboard right now. If you were ever tried the V1, this was going through the back on a channel that the PLA had. It was held by the NUC itself, and you needed to first put the cable, plug the USB-C, then put the NUC. And if you wanted to unplug the keyboard or make any changes, you needed to remove the NUC, remove the cable, then you could move the keyboard. In this version 2, it's much more simplified, and you're able to play around with the keyboard by just unscrewing the front panel, going to the edge of the table, and letting it fall a little bit. Basically, the V2, as people, when I put a couple of photos, they were like, well, but it looks almost the same as the V1. So the biggest difference is there are tons of changes on the V2. They are mostly coming from me actually using the thing and getting annoyed at I'm gonna just want to make a small change or look a thing, and then kind of simplifying it. All right. Right. So we're talking of i7, 16 gig RAM, NVMe drive. This runs about 95% of your Steam library, just as well as anything else. StarCraft, Diablo, Hearthstone, everything just perfectly fine. You have a USB port, I believe that the USB-C on the front may even be Thunderbolt. So at any rate, you can definitely run any screen, any USB-C screen you have. So basically, this one is just a gaming computer. You can do Discord, obviously YouTube, 4K, basically anything you could do with any, not like, let's call it a mid-range laptop. That's what this one is, a mid-range laptop. And here you have the Raspberry Pi 4. Oh, by the way, I'm talking about Linux and I'm talking about Windows and Windows games here. This one runs just as well. Any Linux distro, it does. You can probably put Mac in there if you really, that's what you're into. Now, we're talking of x86 infrastructure. Here we're talking ARM infrastructure. So you could have a Linux here, and you're not doing something stupid. You're running here Linux, and you're able to do something like a Steam Link and a bunch of these cool Linux things that work well as long as you're using x86 infrastructure. Here you have ARM. You can still run Linux distro. Raspbian is perfectly fine. Not so much intended for playing or consuming media, as much as for tinkering. And then we're going to have an e-ink, and you can write Python and see it displayed there, create their alerts and play with things. We're going to have a micro.fat, which is kind of a very old style panel. You could also code Python and play things there, or have it processed to show the little music bars as you listen, as they go up and down, like in Winamp. So this one will be more for tinkering, play with Python, play with electronics, solder on it. It's kind of a little cheaper, a little more hackery. And that one is fancier. That's basically when people say, "Oh, look, people put their this thing, they put a Raspberry Pi, but that's cannot run anything." Well, the difference between being able to run or not run anything on a Cyberdeck is $100. You throw away $100 and they can run anything, and that's what this guy here is doing. We're good. We have the keyboard, we have the KVM, we have all the buttons on the front, we have the Pi, we have the NUC. I think we start to get there. We're going to paste. So now it's the only part of the V2 that bothers me, and I guess that will be one of the things that will probably be fixed on a V3, is the assembly of the back bay. The back bay doesn't assemble great. So we're gonna put now the back panel. So that's the back grill. The NUC has a grill here, which in the past was blocked by the wall of PLA, but now it's open, and we know that this area is all open, so there is actually quite of a current that can go that way and pushes air that way, and we have it open, and we have the grill, and you can actually feel warmth coming out. And also has a fan that pushes heat that way. And the heat that way, we're going to take care of it by putting a fan on top. It's going to suck it up and push it out, which is one in the past. The V1 had the knob to a fan here, which was almost more of a static thing than anything else, because we have a wall of plastic headers. So then really there isn't much of an airflow there can be when you put a fan on top of a wall. Now that is just a wall because it's a wall of headers on the other side anyway, so it adds protection. And we're going to put the fan here where there is an actual push of the airflow that the NUC is pushing that way, and then we're going to push it up. And the heat from the Pi and the batteries and all that, again, we're going to be pushing it up, which should be helpful. We have here this with a crazy number of screws. We're going to just put a couple. I'm not going to put all the screws. I'm pretty sure that if I have here 9 screw holes and in front of you, I put 3 and the thing holds, you'll believe it'll hold as well if I put 9. You're going to see that as I use the screwdriver and it locks, I don't actually do strength with my wrist. Let me go. I just let it spin. My intention here is not to tighten the screws. It's just to not have my wrist work. Those materials are not strong. And originally I did it just for aesthetics, which is add a ton of screws everywhere. And first they were just kind of tapped into the PLA, but now all have these heat inserts. All these, so many screws with so many heat inserts means that even if they are kind of loose, the whole thing holds surprisingly well. Then we're going to plug the power cable here. Okay, now everything, all the cables that go around this direction are already in place. So I'm going to hold them down a little bit with my finger, and I'm going to abuse the HDMI cable to hold everything down. So that way, okay, I'm going to be holding everything down, and put the HDMI cable there, boom. And now we'll have here a good empty area. No cable will run into the fan, and it's a good space for the air kind of come in and come up. All right, so at this point, we have most of the stuff in place. And we know everything works, but really we don't know. Well, we should just hope for the best. So I'm going to plug the screen, and we're going to do a first dry run. And if things work, I'm going to start tightening up those screws, and we're going to put the cover. But doing this test now may help in case something is not really working or doing not right. I mean, I did buy the stuff at the Houston NASA thingy, but of course, it's probably helping China more than Houston. I wish they just sell a stuff they made, or at least was made by. I mean, ideally, I wouldn't mind, instead of paying whatever $17 or $19 for the cap, paying like $39 or $49 even when I'm at the Houston thing. Ideally, I wish it was made by the same people that, I don't know, that makes astronaut clothes or something. It doesn't need to be astronaut clothes material, but, you know, the same company, and you're kind of helping their bottom line and getting something from there. As a plan B, made at least by some U.S. manufacturer, but going there and buying a made in China NASA cap that I could have gotten of Amazon. Not sure how much of help there is for anyone there, but that's what they sell, so that's what I bought. But they need to make a hat that they can sell in their gift shop, and I'll buy it, even if it works, and doesn't matter how many G's it works. All right, so we're gonna do the first test. I'm gonna start with the Pi. There, we see the light go on, so that's good. One thing about the KVM, you hear the noise when it's on. Immediately, I have to push the switch button. For whatever reason, and that may be just this switch, or because I buy the $30 one, maybe there is a fancier one. It only powers the screen on the number one computer plug, because you plugged 1 and 2. 1 is the NUC. The Pi screen will not be powered unless once the KVM turns on and you hear click, click, you switch. Then immediately starts powering the screen for the Pi. Otherwise, it never actually powers the screen for the Pi. I'm not sure why that's the case, but it's consistent. If I didn't push switch within a second of hearing the sound and wait another 4 seconds, then I pull switch and the screen will stay black. But we seem to be in good shape, or not. I do not see the touch. It's not working. Oh, I plug on power only. There is a power only, and then there is a touch. Let me put on the touch. There. Better now. Oh, on who? What do I strap? Okay. All right. So yeah, we get the touch. Everything works. The keyboard, works as well. Okay, so we are good with the Pi. We already have it all working. Oh no, we didn't test the mouse. And I just the port I have in there was giving me trouble. I just got today a replacement delivered, but I put the old one because I am filing that so the keyboard stays good in place. Otherwise, with that, it's kind of too tall. So I still will use the old one, and there is a chance it doesn't work. Let me go fetch the mouse. Where do I have it? It's a monster mouse. I'll do that in a second. Didn't find a big mouse, but saw that one, which should do the trick if it works. The thing with that one and the Raspberry Pi is that sometimes the first time I have to tell the Nook to sync the two of them, and then the Pi can work with it too, with the unifier thing. Yeah, and that doesn't prove that the thing doesn't work as much as that we're using the Pi. So I'm going to now plug. I just plug the power on the back for the Nook, and we're gonna turn the Nook on. Light went on. Now we switch to it. I generally do that that test to make sure everything works before I put the lid here and put the hinges and kind of the other half of the assembly. That's a good point of stop. We still have easy access to kind of fix anything that is not working. But we already are able to have everything. We can see everything working, and we're able to fix anything that doesn't. Okay, so you don't work, do you? No. But I think that just this USB port is the back of it is kind of loose. No devices detected. Yep. A little annoying. Come to the edge. Yeah, this is just this guy. If we don't get it to work, I won't sweat it. It's just a USB female, and all that's going on is that it refuses. It's a little loose. I'm gonna plug to the new USB port, which will be installed there as soon as I can, as soon as I file it with the Dremel. I'll probably do it tomorrow morning. And thanks, Mika. There, boom. I expect that to be fine now. There, you see, and the mouse is working right away. So yeah, all we have here is a faulty this piece of crap. The USB port, it's faulty. Tomorrow I'll just send that one, and I'll use that one instead. Good. Okay, we'll ignore that port for now. It's just the port. Everything else is working fine. This doesn't work. Yeah. Thanks, Micah. I said it a minute ago. Right. So we're gonna proceed, knowing that the USB port for the mouse will need to wait until tomorrow to work. Well, we're talking at the. Well, I mean, everyone can hear me or not? Oh. I don't know. I assume not. I assume, but they could hear you only if they went to the Discord and joined the call there. If they want. All right. I guess, but that may make me sound kind of crazy. Okay, for everyone, I'm on a call with Blasto, and you can join on the Discord channel. So if I talk and it seems that I'm just talking to someone, it's not just my imagination. I'm talking to Blasto. All right, so we're in good shape here. We're gonna turn everything off, and we're gonna keep assembling. Knock this off, and here we're gonna have. Oh, we got again a blur. Now, what is the focus issue here? What are you focusing on? Correct, but the problem is that I don't know how that is done. Besides, I cover it for 3 seconds and then pray. No. Oh, okay, so great. So he'll join to see my out of focus camera. Hey, Zach. I just well, there it is. It just managed to focus again. All right, so we just tested the Nuke works. We're gonna excellent. Yeah, now it's in focus. We're gonna keep going. Yeah, Zach. If you were feeling a little down on a Friday and not feeling very well about yourself and what you do, that's a great place to get your morale up. You can't even get the camera in focus, yet alone something someone will want to watch. And now here's what I'm doing is I'm turning the Pi off by holding the power button like 7 or 8 seconds, so it forces off. Otherwise, the Pi just stays on forever. So now we unplug after our midway test that everything works. And we're going to now secure the front panel. Well, like that. Have the here those guys. Press for the top. Kind of worried about the headphone cable just throwing the whole thing off. It will be my style. I won't bother put all of them. As well. Okay. Again, I'm not going to be putting every single screw now. There are way more than it's needed, just for aesthetics. Cool. And the back panel. Okay, so we'll prepare the back panel. So the back panel has our only instance of an M2 screw, which is going to be the switch for the fan. Get it? Here you are. So what have I done here is just what's called a rocker. No, not rocker, a sliding switch. This is a sliding switch, and I just soldered a couple of very short wires to it. I showed them to the side, so basically that's going to go like this and already pointing towards the fan. It comes with two M2 holes, so that's where the only M2 screws in this build go. Here they are, which were bothering me earlier when I confused them with M2.5s. And the skinny Phillips top is here. I like that all these, when I get all these tools are kind of magnetized, then they hold the screws, holding them with one hand and try to screw with the other. With my sausage fingers, it just doesn't work. Let's get the magic of things holding magnets. So secured. Then the knob to a fan. So this is a 5-volt noctua fan. And what have I done to it? I put a cable to provide power to it and one to go to the switch, and that's all there is. Now the orientation, we want to make sure, and it has arrows on the side, that one arrow is pointing up, and that should be easy. Here we have 2 arrows here. We want it up, and that's going to be easy because you just get the sticker going up. And then in terms of direction, the Nook already pushes air that way because it has its own fan. The pipe has nothing, so I think I want it to be grab the air from here and go up. And to achieve that, we want it to be like that, which is neat because that means we're going to be able to read the sticker while we're typing. It's going to be in the same angle. Now this piece goes installed like that, so that means all we want is the fan to go like this, like so. We have it in place. I already have kind of, I guess I just got screwed in place the M3 washer, the M3 nuts, and so we'll just screw M3 screws. Here they are. I think I'm using 12 or 14 millimeter. If you care, I'll measure them with the caliper. But really, as long as they reach, you're good. And those are hex ends. Here they are. Cool. Right, so we have the fan is solidly held there. Have a little bit of tape here. Just hold the cable. That's going to be the switch for it. Connect them. And that one, which has some tape that is of no use anymore. Replace it. Oh, it's out of focus again. Oh, come on. Yeah. Let me. Yeah, I'm gonna try to do my next stream sober because when I see blurry, apparently so does my camera. Sorry about that. Piece of shit. What's your problem now? Focus. Garbage. I mean, yeah. Maybe I don't think I even installed any Logitech software. Maybe I should have installed something. This is a piece of shit. Oh, come on. Ah, there you go. Right. if anyone says I don't like Zach videos, people can say, well, at least his are on focus, which is something we ask can get to. But I just remove this old tape that wasn't doing any good anymore, and I'll put some new one. Tape for me is the compromise. I'm not using glue almost anywhere in the build, but I feel the tape is okay. It holds things in place in a very removable way. You can undo it without having to reprint or having to like do anything. Just cut it and put a new patch. Okay, and here, this one is going to be going, this goes like this, and that cable will go around and go here. We have the connector for the power. And the only tricky thing is that we don't want it to run into the space used by the back bay. Back bay, we're going to be going here. We want to make sure that they share the space. So we'll have that be that one here. That's not supposed to happen. Right. Here. The camera. So this one is the 920. So I bought the Brio, which was $200. I really didn't care. But my wife bugged me that Wirecutter said that the 920 was the best. I'm like, why will the $50 one be better than the $200? But yeah, let me look up the exact model that he made me get and made me return the Brio. I mean, I don't know how much better the Brio is, but I assume it to be better. Logitech, my Amazon orders. I got the 9. I mean, I just went and it seemed to be their fanciest thing. So I was like, hope if they don't do better than that, that's going to be it. C920X HD Pro. So it's the letter X, 920X. It's the one the wife made me get. So I kind of picked my battle there. I didn't expect really to use the webcam too much. Okay. So here the problem we're going to have is that this little loop, that's the part that I don't like how it's in the version 2, because connecting that is going to be very annoying. We don't have really a lot of space. And if we put that first, which is an option, and then we put that, we really have to hope that the screws hold it. So we'll try that and see if that works. Now it's a little easy to install. Just put that plug in there. And that basically is what runs the back bay, that provides power when we put the Pirate audio. And also because we're plugging all the USB cables to the NUC, means that we are able to use what is called USB to on the go or to go or something like that. That basically you can grab a Pi Zero and make it be just an external drive or plug and then get access to stuff in there. And of course, if it's a 0W, then you're able to SSH from the Pi. And if you really want to use that on the go, and you're like, well, but that doesn't have batteries, of course you still have access to the USB ports here, and you can just plug it here and use it from the battery power. And I plugged that, and now everything went on. No, that was not my plan. Okay, now it's just abort mission. Okay. Calm down. Okay, go to sleep. Cool. So we have the back bay in place. We prepare the fan. Everything has been tested. The only part we have now down here is we have this guy, which is going to be our LEDs to indicate if things are on, which we will plug later. Hopefully it's not too complicated. And yeah, I think we're good. Right, so we'll plug here the fan. Cool. So all that seems to fit and look pretty well. Okay, so this one is 1,000,000 screws. So I'm going to put a few of them, and I think you'll get the point of how it works. We should be okay now to put the little jumper, which I am already unable to reach, without the Pi starting because of it. And we should also be okay to add the hacker hat. Maybe I'll remove I'll do it before putting the back cover. Wait, no, the Pi seems to be on again. I don't know what is triggering the Pi to go on. I'll just not put this thing. Put the hacker hat where we're going to be connecting in a moment from panel e-ink and microdot fat. Here's a couple of big screws in there. Screws with a big top. I probably unscrew it earlier. I don't know where I put them. Oh, here they are. Those skinny Phillips top here. As the time goes by, I start to have stuff around my desk and I start getting confused. That's one, and that's not the other. That's the other. Cool. Now we have the hacker hat in place. Now we can install the back cover. Perfect. And what you want to make sure is that once you put the back cover, everything, like it's when you push one side, it doesn't kind of go at that side, because what it means is you're basically clipping a cable somewhere. In the version 1, it was almost impossible to not clip a cable somewhere. The version 2, there's so much more empty space that all is good. The fan, you can see now, works just fine. Gives a breeze that I'm pretty sure everyone can see on the camera. And now it's off. Right, I'll put a couple of those screws in there. A bunch. I tried for a little while. I tried Raspbian Linux, Raspbian Lite for a little while. Now it just has the Raspbian Basic. Really, you can run any of those. They work perfectly fine. What I really like that I managed to work for a few days and then I just couldn't get it to work again ever was the what is called EDEX, the edX. It's just kind of a bit of a terminal UI with like a spinning globe, and it looks pretty cool. It worked for a little bit, which means it can work on the Pi. But probably I did some sudo apt upgrade, and then it just never worked again. And then it's okay. There is this Swordfish retro terminal or something like that that I got to work a couple times, but also after some upgrade, it stopped working, and I gave up. I spent an afternoon getting one of these things to work, and if 2 days later it stops working because I ran a generic upgrade, I kind of gave up. But yeah, I was more into like the aesthetic than trying to do all the cool features that Kali, all the things Kali can do. Okay, so it was the same. Yeah, it worked for a little bit and then it stopped. Cool. So that's going to be our LED panel. It is there. I put a few screws. I'm pretty sure you can get the pictures of how the rest works. Everything is pretty solid. Maybe I'll add one or two here to hold the back bay in place. Those here. Yeah, if any of you get to have, especially the edX one, but if not the Swordfish Retro, whatever it's called, to work on Pi, you shall let us know. Because I'm pretty sure that a bunch of people will like to have those schemes. Kali is more of a like you should spend quite a bit of time going through training and how all these applications work. But the other two that I'm mentioning are purely skins. And those anyone should, if it works, anyone should give them a go. Yeah, so that seems to be good too. Now we have this indicates basically, this doesn't indicate which system is on. This, can you even see it on the camera? The light on? This doesn't tell you which system is on. What that tells you is which system is active according to the KVM. So the front tells you which system is on. We have the Pi on because it turned itself on while I was messing with it. And now we have the Pi. But now we have the NUC, which what it means is we know the NUC is not going to work because it's off. But the KVM is sending the keyboard and the screen and everything to the NUC. And so this little indicator helps me know which system I expect to see on the screen, which is a good segue to installing the screen. Right, so we have with the little fancier hinges than before. Not that fancy, still PLA and with the screen in the middle. But before it was just kind of one block instead of these little triple things. And also there is a little casing for the nut, so now aesthetically it's a little more pleasant. So we're gonna go ahead and put the screen inside. This screen is thicker than the one on the V1 because it has some extra glass. It looks much better for 20 more bucks. But I did have to remodel this thing to kind of make room for it. The whole thing is not thicker, it's just the inside. It's a little emptier to make room for it. Then we'll just put that in. Put it a little bit up at an angle because that way it gets clipped by the top that it's indented. And then sometimes when I put it in, it makes some scary noises. This time it's not making them, so it's better. Push it a little in. This screen has four tabs, 1, 2, and then you do not see 3 and 4 because I cut them. I marked them with like a knife broke the PCB and then send it with the Dremel. It looks just right. And then now the top doesn't need the space for the two little legs, but in the bottom we do have the tabs, which is good because otherwise, as you can see right now, it may come out on the back. But to avoid that, we're going to put a couple of screws. 1, 2. Screws. There. Cool. Maybe. I'm doing most of the stuff out of camera, I guess now. The camera is just so bad. With the screen, we want to be extra careful when we tighten the screws because this thing is delicate. So we'll generally avoid using the electric screwdriver at all for that. I might rather have a slightly loose screen than force it with the screw and just break it. So now we have the screen solidly in place. I'm trying to get the camera to record kind of the edge of the table so you can see what's going on here. There. All right, so now we have the screen in place. We can add the e-ink screen, the ink screen, which now this one is a little better, and so even when it's not powered, you're gonna still see everything in it. And so we put it in the little space here. I make a lot of indents for the screens, meaning if you put it vertical, it doesn't go in. You have to kind of put it at an angle because there are holes. You can see them there, but you can't believe they are. And so basically this, you have to put it into the hole at an angle, and then it just falls into place. It's not that this really holds it into place, but it definitely helps a little bit. We want to make sure that it's perfectly flush with the plastic. So I'll wiggle a little until I get it to be flush. There, I heard the click. Perfect. Now it's all perfectly flush. Once we have that flush, we can add, I made a little panel for the back to hold it in place. Panel, here we have it. It has all the, actually this is from a design I put on Thingiverse to hold that specific screen, and I just modified it a little so it fits in here. So I'm gonna put that on the back, push it in. Because the screen was flush, that should be, again, touching the plastic. That's going to hold the screen looking sharp. And we have a couple of screws for that. One second there. Oh, sorry, this just went out for a moment to turn off the Dyson purifier. For whatever reason, thought that the air got dirty and just went full blown. Just went to turn it off. Plus, were you saying something? Yep. Is it quit farting in your workspace? That order I will not take from nobody. It's my workspace. If if anything, learn from what happened to the Dyson purifier. Try to do something about it, and I'm gonna kill you. You're gonna be turned off. I don't know if you saw. I just put a couple of M4 nuts here, and that's basically with the M4 screw what's gonna get the hinge to work a little bit like a hinge. No, it's not a real hinge, but a hinge wannabe. And I think that needs a bigger. I'll just use the manual Allen. That needs a bigger tool. There, go in. Yeah. Blaster reminding me that I'm on YouTube, so I should tell people to like and subscribe. But it's the first time I do a stream. I'm on YouTube, but I don't really remember that I'm on YouTube, and I honestly don't really understand why do I want the subscribe and like. So makes it hard for me to remember to ask for those things that I don't know what they are for. But if you know that you're gonna get something out of liking or subscribing, if you do it for me, I'm happy if you pass. I don't do these things for the internet points. Right. Okay, so now we can see the hinge is good enough to hold the screen at about any position, and that's a lie. So we're gonna tighten it up a little more. Okay, we're gonna let it be here. And what can we do now? We're running almost out of parts to install. We have what's going to be the back panel here, and the back panel will have the hacker hat in the front, which will have the microdot FAT and also a row of GPIO for us to play with. So we're going to secure that with a couple of screws. Which you could have guessed at this point, since if nothing else, you've seen me put screws around. I'm just getting now a bunch of screws at once. Just have them nearby. Okay. I wish people could talk as I am doing that. I think it would be more entertaining for everyone involved. Now we have the hacker hat is pretty solid here. And I put 2 of the 4 washers. Later I'll put the other. Okay, so now this step matters. We kind of put the cables. Oh, hear a loud noise. Put the cables. We plug the. Oh, Blast, are you on an airplane? Here's. Oh, now it's quiet. So we plug the 7-inch screen now, HDMI and touch plug. Oh, hey, bud. Yeah, I'd rather have more people chatting than just me hearing myself. All right, and now we'll put a couple of screws in there. And actually, I realized I forgot one item earlier. So we're gonna go back and do one item because it's a very critical one. Is the strap that my wife made for this thing, and we forgot to put the D clips for it. So we're almost done, but we're gonna put the D clips. Actually, maybe I can put the D clips without, just from the outside. I'm skipping a lot of screws because you've already suffered, endured through 2 hours of me putting screws. So anyone assembling that, I'm pretty sure that if something is missing from this video, it's not gonna be me putting the second screw or third screw on a row. But if for some reason there is a screw that you really, really want to have me put on, do let me know. I don't want you to lose sleep because of that. Yeah, last I can hear you. No. Cool. All right, so that is working. It's good. As I was saying, we're gonna put the 2 clips on the side. We're gonna the right way. So these D clips, those are the ones that are gonna be our strap. I don't trust just screwing from the outside like this, and they're pretty long, because I forgot to do it, and I'm not gonna have you go through it and see it now. But basically, I put a nut on the other side, and I was thinking the other day that I'm gonna change it to the self-locking nuts, and the ones that come with a little blue thing, so they hold a little better. Because the last thing I want is that it just falls off the strap, because that screw comes loose. But for right now, it's gonna be pretty safe to just put it from the outside. Yeah, I took the hat off because Blasto saw that maybe one of the reasons the camera was going off focus is that we'll pick my cap and focus on it. So I took it off. If now it's working better, then that is something. If someone can just let NASA know that their caps shouldn't be throwing cameras off focus, that's not nice. That's a lot. If you're watching someone working on Mars, and the camera goes off focus because of the cap NASA made, that would be embarrassing. Right, so now we have the D clips on the side. Yeah. All right, I think we're in good shape. We're gonna go ahead and do it's a very nice strap that my wife made. Pretty proud of this thing. You don't feel how comfortable it is to carry. And then he put a couple some fancy hardware to it, little clips, all that. Yeah, but was mentioning how so that strap. She made the strap for the first one, which you can see photos on the side, and the style is the same. So it's more about the hardware and how it is done. It is very simple actually to make a strap, and you know why it's simple, because someone else did it, and that's what makes everything simple. So you grab one end where you'll have a clip. In this case, is this kind of, I think those are called HK snap clips. They are neat because they are like very thin. They're supposed to be pretty reliable. So one end where you have a clip, you'll do a loop around the clip and just sew directly. And I like that she makes these boxes because they are much stronger and also they look pretty cool. Now the other end, there is a little more going on. So the other end, what you do is you go twice through one of these pieces. I'm not sure exactly what the name is. That these kind of two separate vertical holes with like a bar in the middle. The top one just passes through. Then you go around, you come back, you do a second one under. That second gets sewn again in one of those boxes, which means we have this piece is not going to move, this piece is not going to move. The one on top will be able to move. And so what we do is that we then have on this kind of side that can grow, we just put one of those HK snaps. There is a little loose, but just by the nature of the strap holding weight, it's going to fall kind of neatly halfway through at whatever it's going to fall halfway through at whatever length we're setting this piece on. So it's really just three pieces of hardware and these two boxes of sewing, and gets you that's how you make a strap. And you can make it with as cheap as a hardware that you want or as fancy. I mean, as fancy as you try to go, I don't think you're going to make it to $20. These things are very expensive. Unless I assume you go to Etsy, there people is able to charge fortune for what is nothing. Oh, I'm not putting that away. Right, so we're gonna clip it. And how do we want it to be? I want to be my left side. I'm picky with these things that make me feel a little like I am monk. Clip. Clip. All right, so we're gonna turn this thing on a second time, and that's gonna be the second and last time we turn that on, unless it doesn't work. That is what I mean. Sorry. Okay, so you're asking, did she make the strap itself, or did she just buy the strap material and sew the hardware? She bought the material, and so basically she did all the sewing you see and the assembly. The strap itself, she did not make. I'm pretty sure that you cannot make that at home. It is several layers of different materials. I think there are some polyester part in the middle. There is the kind of fabric style on the top, and it feels pretty luxurious. Okay, so we're gonna power the NUC here. We're gonna use. I mean, there is no really need to plug the Pi, because as we like we did earlier, you can turn it on off the 18650s. But just to show this cable working, we're gonna do it in a moment. I'm gonna go ahead, turn this thing on. No, she doesn't. She didn't make the strap. She kind of sews things. But she did make all the masks we were wearing last year. She makes all the dog harnesses. So it's quite a bit of a staff. But yeah, she buys the fabric and then does the sewing. Oh, the screen looks like shit. I must have plugged something wrong. You cannot see it, but the screen looks very bad. I will check later why does the screen look bad, because the fact that you cannot even see it makes it's not needed for me to spend time fixing it. But the Nuke works, and now we're going to turn on the Pi. So now we have the e-ink plugged, and the Pi is already set with the Python script to run on load. So we expect the script that refreshes the e-ink to kick in. So it should, and it, oh boy, I'm an idiot. Those things are not Wi-Fi. You need to plug it. So once I plug it, I expect that to refresh and update. And then the bottom one, we're going to plug it as well. And then we're going to put the microdot, but it should just work right away. So plug one ribbon for the microdot, one ribbon for the e-ink. Let's put it right. I did not put that right. Now it feels a little better. Let's plug that one. Okay, so now we see that it's refreshing immediately as soon as you plug. It runs the script and go on. That's your problem. It refreshed, but it didn't actually show the stuff. This side is fine, and this should be fine too. I'm gonna restart. Reboot. And what also should be working is the microdot, but maybe we'll go one thing at a time. Refreshing. I don't know if I did something wrong. What about the... Oh, I think I know what's going on. Oh, but I'm actually not sure I know myself very well. I just put the microdot display. I don't know, maybe what was happening was that the Python script was preparing the e-ink, then was trying to talk to the microdot, and then it will fail because there will be an I/O error with the microdot not plugged. So I just plugged it to see if it works. Obviously, the Python script is running in order, and it can crash, but drum roll. Oh, there it is, and now everything works. Cool. So what was happening is all this is run from the same Python script. You could obviously add error handlers to say, hey, if you don't find the microdot FAT, just keep going and work just off the ink, or if you find only the microdot, ignore the if you only find one, run off the other. I didn't do that error handling. So the microdot FAT is a display, but it's basically, in this case, 1, 2, 3, 4, 5, 6 displays, each one with, I don't know, maybe 100 LEDs. In this case, are all of the same color, all green, and there is one version I have in a drawer that is all red. And you're able basically to lit any of those LEDs independently and have them flash and have them move. And that way you can show text, make effects. I think a pretty cool one is the one where you're listening music and the bars go up and down. You cool, in theory, have almost watch a movie in there with all these lights. And it does look pretty neat. And I think with that, we... No. I haven't played games on the microdot FAT, but I guess you should be able to. But was mentioning that maybe you could play run Tetris on it. Now we can see you can see that it says we have 4 volts on the battery. It's there, 4 volts, and we have it's at 117 degrees. 117 is not too hot, so I don't know if we're going to get much from turning the fan for a moment. But what we should always immediately see is that the power level, once we plug it to a sourcing power source, so we're going to do that right now, we should it jump to like 410, 420 by the time it's full. So we're going to use that, turn that on. Power source. Oh, I think I have to push a button to enable the USB. There, now the USB is enabled. So now I'm going to hold it again, and if the camera is nice, we'll be able to see the 4, and then I'll plug the power. Now it's not immediate. Why is not immediate? Because it's an e-ink display, so I'm running a refresh every 10 seconds, which means I plug it. It doesn't literally mean in 10 seconds it'll refresh, because I plug it halfway through a refresh. But once the refresh kick on the 10 second, you can see that it went to 416. It was a partial refresh for those kind of nerds on e-ink. So the logo didn't change. All was refreshed is kind of this bottom area, bottom section. And then every 3 minutes, refresh the full screen, because this refresh every 10 seconds, which on 3 minutes will be like 18 times, the numbers will become unreadable by the end. Cool. So everything works. It's been assembled, of course, took 2 hours, and this is ridiculous in the sense that I didn't do any of the soldering, any of the printing, any of the putting the heat inserts. Everything just went as smooth as it could have been, and it still took 2 hours to assemble. So this is definitely not something that you put the ones that is quick to put together. And also I just skip 70% of the screws. Yeah, so I don't know if anyone is. Blas was asking how long it take to print. The main part, the biggest chunk, it was a 50-something hour print. First, I did the print. It could have done much better. I print on 26 hours at 15% infill, and actually 15% infill is good enough. It works. It's fine. The problem is the heat inserts at 15% insert, they don't hold in place. You put the heat insert and the whole thing just turns. What I should have done, and you should do if you reprint that, is you can print it at 15 or 20% infill, that's fine. 15 was good. But add much higher number of walls on any kind of, in any place, basically anywhere there could be a wall, make it much thicker. So basically all the heat inserts have enough plastic to hold onto something. What I did instead was bump the infill to 60, so there is way more plastic everywhere, which holds the heat inserts in place. So it did the trick, but it's a little like a cannon to kill a fly. And there was no need to add so much plastic just for the heat inserts. So that was 50 hours. Everything else is maybe about as much. Basically, one part is as much as all other parts together. And the biggest difference is going to be the infill you use, I think. Cool. I don't know if anyone has any questions or saying anything. If not, I think we may call it a stream here. And that is the first stream I did in my YouTube channel. So thanks for staying around, the dozen of you. And good night. Oh, I guess the last thing, I don't know if anyone wants to see, will be that obviously you plug the pirate audio, and it's just going to work, and you will be able to listen music. I believe now I have a few albums from the Beatles. Thanks, everyone. I'm going to hit end stream as soon as the thing loads. Well, I mean, it's just going to ask to go to a website, which is the thing I don't like about pirate audio. Oh yeah, of course. If in terms of Plus was mentioning to find more information, I put together a site msglab.co. I guess it should be everywhere where I post anything. Uh, yeah. So you go check. I put a lot of information about this specific deck on my site, but really, if you're interested, if you like what you saw on that stream, where you should go first is the Cyberdeck Cafe. Join the Discord and go to their website, our website, because you're going to see a lot of cool stuff and different ideas that people is putting together or has put together. And I have basically this deck started as a version of another deck from Boot, the Virtuscope, and my first attempt was a modification on the Virtuscope, and it's posted on the Cyberdeck Cafe. So if you want to see how I got here, where I started, and lots of cool stuff by other people, to check cyberdeckcafe.com. And if you're just interested in building that one, msglab.co, there has plenty of information. All the parts used, everything is links there for you to go on and build your own or a version of it, which some already have. Cool. Anyway, the pirate audio went on, so I'm gonna hit end stream. Thanks all.